sampai di lokasi proyek. Selalu ready stock dan pelayanan profesional adalah komitmen kami. Dengan pengalaman dan pelayanan yang teruji, maka jangan ragu untuk menghubungi kami. Kunjungi website kami di www.multibangunpatria.com.
Setelah sukses mengadakan workshop dan webinar pada beberapa tahun sebelumnya dengan antusiasme dan testimoni yang luar biasa, dengan ini kami mempersembahkan Multibangun Engineering Hub. Multibangun Engineering Hub adalah sebuah program terbaru dari PT Multibangun Rekata Patria yang berfokus pada pengembangan pengetahuan dan inovasi di bidang geosintetik. Program ini menyediakan berbagai kesempatan edukasi dan jaringan untuk meningkatkan pemahaman serta keterampilan para mahasiswa dan profesional melalui berbagai aktivitas, antara lain webinar yang terbuka untuk umum dengan topik seputar geosintetik dan aplikasinya yang relevan dalam industri. Workshop dirancang untuk para profesional memberikan pelatihan teknis mendalam serta pengalaman praktis yang dapat diterapkan langsung pada proyek yang relevan. Multibangun Goes to Campus adalah program khusus yang menghadirkan kuliah tamu dan workshop yang dirancang khusus untuk mahasiswa teknik sipil menghubungkan dunia akademik dengan wawasan industri. Dengan menghadirkan sesi yang diisi oleh para ahli, studi kasus nyata, serta diskusi interaktif, Multibangun Engineering Hub bertujuan untuk meningkatkan pengetahuan dan pemahaman industri mengenai aplikasi geosintetik yang lebih luas, mendorong inovasi dalam pengembangan konstruksi dan infrastruktur yang lebih efisien dan berkelanjutan, serta membangun koneksi yang lebih kuat antara mahasiswa dan profesional melalui kesempatan jaringan serta pengalaman belajar secara langsung. Melalui kolaborasi antara teori dan praktik, Multibangun ingin memiliki andil dalam memberdayakan semua lapisan stakeholder yang terdiri dari insinyur, kontraktor, hingga calon pemimpin industri untuk mengintegrasikan teknologi geosintetik dengan lebih efektif dalam setiap proyek yang mereka kerjakan. Jangan lewatkan setiap event yang Multibangun Engineering Hub adakan dan bersama menciptakan solusi rekayasa yang lebih cerdas, berkelanjutan, dan inovatif.
Selamat pagi Bapak, Ibu, dan Sobat Multibangun dimanapun berada. Senang rasanya saya Rifa dapat hadir kembali bersama Anda di webinar kali ini. To everyone streaming from outside Indonesia, we welcome you to this webinar. For your information, this webinar will be conducted in Bahasa Indonesia, but the presentation and Q&A session will be in English. Webinar ini merupakan webinar keempat dalam rangkaian program terbaru kami, yaitu Multibangun Engineering Hub. Kepada Bapak, Ibu dosen yang mungkin ikut hadir secara online pada pagi hari ini, kami sampaikan bahwa Multibangun terbuka untuk kolaborasi dengan universitas maupun organisasi atau himpunan mahasiswa dalam mengadakan Multibangun Goes to Campus, sebuah acara yang terdiri dari kuliah tamu dan mini workshop aplikasi Tensar Plus yang dirancang khusus untuk mahasiswa. Untuk acara Multibangun Goes to Campus selanjutnya, kami akan mengunjungi Universitas Jenderal Sudirman di Purwokerto pada bulan Oktober 2025. Jika kampus atau organisasi Bapak Ibu berkenan untuk join acara Multibangun Goes to Campus selanjutnya, silahkan hubungi saya pada kontak berikut ini. Selanjutnya, tanpa berlama-lama lagi, kita akan segera mendengarkan presentasi dari pembicara utama kita, John Buckley. Sebelum kita panggilkan pembicaranya, saya akan membacakan profil beliau. John Buckley adalah seorang insinyur sipil lulusan Queensland University of Technology. Beliau juga memiliki sertifikasi manajemen dan gelar master di bidang teknologi perlintasan jalan. Pengalaman beliau meliputi di bidang aplikasi geosintetik, seperti perkuatan struktur tanah, jalan, serta fasilitas penampungan limbah. Belakangan ini, John Buckley juga terlibat dalam pengembangan bisnis dan teknologi, juga riset untuk solusi pengelolaan limbah serta sistem fondasi. John Buckley bergabung dengan Tensar Internasional pada tahun 2014 setelah 16 tahun bekerja dengan distributor utama Tensar di wilayah Australia dan New Zealand. Ia telah menerbitkan berbagai makalah ilmiah, kini bertanggung jawab atas seluruh kegiatan bisnis Tensar di wilayah Australia dan Selandia Baru. Baik, Bapak Ibu, apabila ada pertanyaan, selama dan setelah presentasi berlangsung, dapat langsung menggunakan fitur Q&A yang terletak di bawah layar Anda. Pertanyaan harap disampaikan dalam bahasa Inggris. Pastikan tetap setia menunggu sampai akhir acara karena, seperti biasa, kami akan mengadakan kuis berhadiah total Rp750.000 untuk 3 orang pemenang. Simak keseluruhan presentasi karena pertanyaannya akan berkaitan seputar presentasi yang akan dibawakan oleh pembicara kita hari ini. Alright, John, are you ready?
Yes, thank you, Rifa. And many thanks to Multibangun and to allow or to invite me to present to you guys through their engineering hub. So I really appreciate the opportunity. I'll begin by sharing my screen. Just bear with me, and we have this one. Share. Okay. All right. So everyone should be able to see the title slide now. Thank you for joining. Appreciate your time. So today's topic is Geogrid technology in paved road applications. The presentation itself will be split up into 2 parts, where the first part I'll discuss the actual technology, give you summaries of our research programs that we've been involved with for stabilisation geogrids. And then the second part of the presentation will be on our software, and we'll have a demo of relevant Tensar Plus modules for roads in general. Okay. So thank you for the introduction. I'll move straight into the presentation. So why do you need to know about geogrid stabilisation for roads? There's a few aspects. My aim in this presentation is to give you an understanding of how these geogrids can reduce pavement thickness, extend pavement life, and you can see a nice graphic there on a geogrid stabilised pavement, asphalt pavement, and the traffic spectrum that can support over its design life. And then we can demonstrate how we can save cost, time, and carbon on pavement projects. So in this presentation, I'll explain the fundamental behaviour of stabilisation geogrids, and I'll prove these concepts, which will include an improvement in bearing capacity of the system, enhancing the aggregate modulus, improving compactability, especially over variable subgrades, and improving the rutting performance of the pavement. You know, that's our main performance metric, rutting. Okay, so let's quickly talk about the main concept of stabilisation and the fundamental mechanism behind this. And it's one of what we call lateral restraint of the aggregate, particularly when a out of plane or a vertical load is applied to it, where the geosynthetic is placed horizontally. Okay, so the main function is lateral restraint for stabilisation to reduce subgrade and surface deformation over the pavement life. And if we now focus on this graphic down the bottom here, the bottom right, there's 2 mechanisms that are occurring at the same time when a stabilisation geogrid is employed in the pavement. So under wheel traffic, what we see if we first look at an element of aggregate above the geogrid, so the base course, if we can see this element now flashing on our screen, as this system's being trafficked, what this element of aggregate will experience is an increase in confining stress. Okay, an increase in confining stress, which ascribed to the stress strain or stress hardening behavior of aggregates, will lead to an increase in resilient modulus or resistance to permanent deformation of that aggregate. Okay, increased resilient modulus. Now, then if we look at an element of typically subgrade clay below the geogrid, as the wheels trafficking this system, what that tends to, or what that will experience is a reduction in shear stress to that element of subgrade clay. Okay, so what that does through stress softening behavior, if we can reduce the applied shear stress onto the clay, we also increase the resilient modulus of the subgrade. Okay, so that's reducing aggregate and subgrade deformation over the long term life of the pavement. So there are other mechanisms at work as well, but they all link together to improve the parameters of the unbound aggregate in terms of its shear strength, its own bearing capacity, and its compactability. It's able, or stabilization geogrid is able to do this through confinement with stiff geogrid apertures through interlocking, and it restricts lateral movement and provides lateral restraint to the aggregate particles, okay, increasing the stiffness and bearing capacity of the geogrid stabilized layer. All right, so that explains the concept of stabilization. Now, I'll get straight into some full-scale relevant paved road research and trials. So the first one we'll look at is a study that was done in West Virginia back in 2010. It was a comparative study, and it was instrumented with earth pressure cells, both in the aggregate layer and within the subgrade. Okay, so the subgrade was a field constructed subgrade to achieve a target CBR between 2 to 3%. And vertical earth pressure cells were installed in the subgrade to measure total horizontal stress. And also vertical earth pressure cells were installed within the 600 mil thick crushed limestone paved section to measure the total horizontal stress within the subbase layer. So the 4 sections I mentioned were a control, 3 other geosynthetics, which included a 70 kilonewton a meter woven geotextile, a biaxial geogrid, and a multi-axial geogrid. Okay, and then this was trafficked with an 18-ton test truck. So what the results showed were that the multi-axial geogrid section had the highest horizontal stress within the subbase, but the lowest horizontal stress within the subgrade. Okay, and I'll show you the results in a minute. If we just click over to the next slide, and I'll highlight the multi-axial geogrid data there. So the red line represents the control. So what we're seeing here is a graph of total horizontal stress on the vertical axis versus truck passes. Okay, and this was an 18-ton test truck. So we can see in the stress profile within the subbase layer is showing the highest level in the multi-axial geogrid section. Okay, so that's representing that confining stress applied to the aggregate. It's the best with the stabilization geogrid or the multi-axial geogrid. Now, if we look at the earth pressure cell within the subgrade, once again, we've got the same graph of total horizontal stress versus truck passes. The lowest, by quite a large margin, is the multi-axial stabilization geogrid, and the highest is the control, which we'd expect. Now, the woven geotextile, 70 kilonewtons a meter, is shown just below, for about half the test, it's performing just below the control section. Even though it was a stronger product, not necessarily performing that much better than the control until it started to engage just after halfway through the testing. Okay, so this is helping us to prove our lateral restraint concept. Another aspect that we want to prove is an improvement in subgrade bearing capacity. So we can do this by looking at the differences in applied stress to the subgrade clay through multi-axial geogrid stabilisation. So here we've taken a textbook chart of different consistencies of clay from very soft to stiff. On the horizontal axis, we have essentially the applied stress to that clay. On the vertical axis, we have its corresponding resilient modulus, which we can correlate to CBR by a factor of 10. So if we follow the red arrows, it typically represents the control condition, where without any geosynthetics, the CBR was around 3%, okay, for a medium consistency clay. If we can reduce the applied stress on that same clay through effective geogrid stabilisation, we come down to about the blue arrow and go across, and it represents a resilient modulus of about 50 or a CBR of 5. Okay, so in this particular case, and this can be quite case specific, we've effectively increased the subgrade strength from a CBR 3 to a CBR 5. Okay, but it is very case specific, just be aware of that. The next study I'd like to show you is one which proves the concept of enhanced aggregate modulus. And this was an in situ investigation of a deep strength asphalt pavement done in Arizona in the US about 10 years ago. And it was done with an apparatus called an automated plate load testing machine. So what this does is that if you're familiar with the falling weight deflectometer or an FWD, that applies a seating load and then a kind of a dynamic load to the pavement. So, one or two or more hits. But this apparatus applies a high number of cyclic loads to the pavement, and it's able to do this very quickly, and you're able to very quickly back analyze the strengths of different pavement layers in the field. So this was done for a deep strength asphalt pavement. Now, deep strength asphalt is a deep layer of asphalt with a aggregate base underneath it directly. And just to give you an idea of some of the aggregate characteristics, there's a grading curve and a photo. But if we look at the permanent deformation characteristics, what we want to see over a high number of load cycles, cyclic loading, is a fairly flat permanent deformation profile, similar to this purple line. This would represent a high quality, well-compacted aggregate. What we definitely don't want to see is something like the red line, which is a very poor quality aggregate heading towards what we call a ratcheting failure. But a very stable material would exhibit a line similar to the purple line. The actual permanent deformation results from the testing from this APLT apparatus are shown here in the bottom right, and you can see that they fairly closely resemble the purple line representing stable behaviour. Okay, so what are the characteristics of this particular pavement? I mentioned deep strength asphalt, but the subgrade CBR was not very low. It was actually reasonably high, and typically higher than where you may think about using a geogrid. It was 10%. But this particular pavement had a high percentage of heavy vehicles and easels over 8 million, 8.5 million actually, as a design value. So for that reason, there was scope to include a geogrid, not so much to reduce the aggregate base thickness because it was already heading towards a minimum thickness anyway, but there was scope to potentially reduce the asphalt thickness. And this was done by looking at the design method employed here for this pavement, because it was in the US, is AASHTO 93. Tensar's had this as a module in its software for a long time, but it looks at layer coefficient values for unbound and asphalt layers. And based on the thickness and what's called a drainage coefficient, they're multiplied, then summed up to come up with an overall structural number for the pavement. So without the geogrid, this particular structural number, don't worry too much about the absolute value, but the relative differences, it was 0.12. But by adding the Geogrid, this increased to 0.22, enabling a 40 mil thickness reduction in the asphalt. Okay. So this is an example of it here. These are the different sections. You can see the subgrade modulus, the actual structural number for the pavement, and what the achieved easels were for each of these. So this 40 mil saving in asphalt up front, this was a net saving, so it did account for the install cost of the Geogrid. This net saving was about $120,000 US up front. Okay. So then that was fine. It was nice to have an upfront saving on this project, but during construction and as they finished off the aggregate basement layer, they brought in the APLT, and you can see the device here. It's a trailer-mounted rig, and they actually measured what the composite resilient modulus of that layer was in the field, and they were able to back calculate this layer coefficient value, and it was actually higher than what was considered in design. So what that meant was there was an increase in life from 8.6 million easels to just over 18 million. So it amounted to 113% life extension as well, which could be quantified by this APLT apparatus. Okay, so it was due to the higher layer coefficient. So there were two benefits in a nutshell. The first one was to effect an upfront saving of about 120K US. The second one, derived from the APLT results, was 113% life extension. So they have an insurance policy with additional traffic capacity that this pavement can withstand. So this automated plate load testing equipment is an important technology for Tensar. We've used it over a period, probably almost 15 years, and around, mostly always in North America. It is an expensive piece of equipment, and it's a bit hard to replicate that outside the States where it was originally developed. But we've done over 60 sites around North America. And so far with Interax, we've got 15 sites so far, which have given us very good results and a good understanding of the behaviour. So what I'd like to talk about next is another concept I mentioned earlier, improving compactability. So we've worked on this, once again, over about a 15-year period, specifically with Caterpillar equipment, Caterpillar rollers, and their intelligent compaction technology, which uses a parameter called machine drive power. So they've developed this specifically for CAT equipment, but it's a soil compaction measurement technology which enables a compactor to act as a proof roller, and it really just measures in real time the rolling resistance of the drum to give an indication of the soil stiffness. So to get an idea, the looser the material is, the harder it is for the drum to traffic over that material, and vice versa, the harder the material is. So, material can be calibrated for this property called machine drive power, and then the compactive effort can be adjusted accordingly in terms of level of vibration and number of passes. So it's quite a novel technology, and it's very interesting. And it was employed at a site in North Dakota, at a state highway site, I think, at Marmarth. And you can see the layout of the test beds, or they call them test beds. They're trial sections, where we had about a 60-metre section with 2 layers of multi-axial Geogrid adjoining a 30-metre control section with as you'll see, a highly variable subgrade in both sections. So we're looking at test beds 4 and test bed 6. Now, you're probably wondering, okay, well, how does machine drive power, or MDP, compare with more established pavement evaluation techniques? And these charts, I'll just run through them one by one, give you a nice indication of this. So we'll just focus mainly on test bed 4, which was the Geogrid section. If we compare it with these red dots, which are modulus values from lightweight deflectometer, you can see there's quite a good correlation there, okay? Then if we compare it with FWD results, modulus derived from FWD, you can also see that there's quite a good correlation and it's fairly consistent across that section. The next one is nuclear densometer results in these greenish diamonds, and you can see also a good correlation. And the last one is looking at moisture content of the pavement materials and how it relates to optimum. And these are the black diamonds, and once again, quite a good correlation. The last one is DCPs, but there are only a couple of those done. So those 4 are the best correlations. So you can say it's pretty indicative of pavement performance, and it or at least compaction, and it relates to it well to established techniques. Okay, so the results. So this technology enables real-time mapping of compactive effort by pass, and we can see here the 2 results. So we've got the stabilisation geogrid in TB4 versus the control. Now, essentially in the geogrid section, they were able to achieve, even though it was highly variable, the subgrade was highly variable, they were able to achieve target compaction in 5 passes evenly through the 60-metre section. And don't forget, this was a salvage-based material, so it wasn't the best quality, but they were able to get it down to an acceptable compaction standard for the project within 5 passes. For the control, different story. Very variable, high number of passes. They actually lost track of the number of passes, and they didn't achieve their compaction. So there'd be some potential remove and replace options, or potentially chemical stabilisation. There's other options there for that. Okay, so that's about compactability. I just want to quickly mention we've also done work on expansive subgrades. So this was done by a professor called Jorge Zornberg and his researchers at University of Texas in Austin, going back 2018 for FHWA. Essentially, a very wide range of geosynthetics were evaluated across 10 sites in 80 sections to look at improvements in environmental performance and traffic performance. So particularly longitudinal cracking, transverse profiles, and rutting. Okay, and essentially the multi-axial extruded stabilisation geogrids shown here, 4 of those out of the whole lot performed in the category, most of them in excellent and 1 of them in very good. So compared to a lot of particularly biaxial, different types of biaxial products, the multi-axial geogrids perform the best. Okay. Right, so I'd like to talk about improving rutting performance now, and this was an Interax trial that was done in Norway a couple of years ago over about a 13-month period. Okay, it was on an entrance into a quarry, so a very wide spectrum of quite heavy traffic, amounting to just over 67,000 standard axles. So what we've got here are 4 different sections, but just remember there's essentially 2 replicates of each section within that. So sections 1 and 2, they're based on a 200 mil crushed aggregate thickness, 70 mil of asphalt with and without geogrid. Sections 3 and 4 are 200 mil of RAP, recycled asphalt planings, with 50 mil of asphalt, without and with geogrid. Okay. Underneath all of these sections, though, because it was a rock subgrade and they wanted to achieve strike through of the aggregates through the geogrids to represent true behaviour, they installed 150 mil of sand, okay, to enable that to happen, rather than potentially the rock crushing onto the rock in the aggregate crushing onto the rock subgrade. So some photos. Here is the sand in the top left going down, then the geogrid in the top right. Bottom left is the RAP material, and the bottom right is the asphalt. So rutting performance was looked at with this device here, this vehicle, which is a laser profilometer. So this provided transverse and surface shape scans throughout the trafficking period at 4 different time periods. So it was done once before trafficking, twice during trafficking, and then once after trafficking. Okay. So average rut depths were calculated. You can see the 4 in this graph. In this table in the bottom right hand side. You can see the 4 different readings, and essentially, if you focus your attention on the green highlighted column, it shows that for each of the Geogrid sections, sections 1 and 3, they had a lower increase in average rut depth than their control section counterparts. Okay. So that's a good result, but we want to make sure that we're actually comparing apples with apples, and that each of these 4 sections were constructed to the same thicknesses. So after the testing, they did some excavations, some trenches through each of the sections to determine that, and it was found that on average, the sections weren't exactly the same, unfortunately. So in sections 1 and 2, in the Geogrid section, it was about 70 mil thinner than the aggregate thickness was 70 mil thinner than its control. In between sections 3 and 4, the asphalt was about 7 mil or so thinner, and the wrap base was about 50 mil thinner. So we weren't directly comparing apples with apples, and this information is good to know so we can adjust or normalize the results somehow. And the way that we do this is we look at creating a model in a mechanistic empirical design package or analysis package, and the researchers here used Ashto Ware from the US, and this was calibrated against the observed results for the control sections over the trafficking period. Okay, and you can see the results here in terms of rutting, and the actual measured results were the circles. The black line is the model, and there's generally pretty good agreement. So we've established a model for each of the sections where we can make adjustments and hold certain things constant to properly evaluate performance. Okay, so the first thing that we held constant was we looked at if we match the thicknesses appropriately between the stabilized and the control sections, what level of rutting would we expect to experience? Okay, so between sections 1 and 2, with the aggregate base, the control for the same thickness would experience 43% more rutting, and for the wrap sections 3 and 4 in the green, 24% more rutting in the control for the same thicknesses. Then if we wanted to match performance based on the same target rut depth, we would need 30 mil more asphalt in the control for section 2 and 100 mil more aggregate base. For between sections 3 and 4, we'd need 15 mil more asphalt and 110 mil more wrap to get the same target rut depth. Okay, so this is important to do to get the best understanding of the performance differences. But this full-scale trafficking test, it was able to demonstrate a significant increase in pavement life from the Geogrid stabilised section, significant reduction in pavement thickness, or you can combine the two to get somewhere in between. So we can save initial construction cost, time of construction, on the carbon footprint of construction activities, and also thinking about the life cycle costs in terms of reduction in cost of maintenance and the associated carbon footprint over the life of the pavement. Okay. The next study I'd like to show you is with an accelerated pavement tester over in South Africa, run by an organisation called CSIR. This was done with Interax in the last couple of years, and it was over a fairly competent subgrade with a CBR of 7. And once again, a directly comparative study with the control, 200 ml of select fill, 150 ml of CTB, and 200 ml of a fairly good quality base material with 50 ml of asphalt. So, and this has been done before. It's not typical, but the Geogrid itself was installed directly under the cemented layer, the cement treated base. Okay, and you'll see the benefit of that in a minute. But the accelerated pavement tester was able to increase the wheel load. It's a dual wheel, one half of a standard axle, from 40 kilonewtons to 80 kilonewtons at the end of the test. Okay, so it's 160 kilonewton axle load. All up, if you sum all these passes, it's just over 1 million, and that's equivalent to, as the axle load increases, 14 million easels. Okay, so we took this testing to 14 million standard axles. A quick video of the APT, just showing how the wheel traffics back and forth. Does that for each of the sections. Let's move on. Okay, and these are the results. So here we've got trafficking in terms of easels on the horizontal axis versus the mean rut depth. Now, this red line is the control behavior. Okay, so that we can see that what the final rut was, it was approaching 25 mil. And up until about halfway through the test, the stabilized section was performing just only slightly better than the control until water was added into each of these profiles. And you can see here that the control experienced quite a drastic deterioration in terms of rut depth. But the stabilized section, you know, it basically kept going at about the same slope. Okay, so it exhibited very good resilience when water was added to the, the pavement formation, and particularly affecting the cemented layer, where at that stage, halfway through the testing, it's probably cracked. So the effect of water could be quite drastic without a effective stabilization geogrid to help provide that lateral restraint to the cemented layer, which is now acting in an unbound manner. Okay, so 50% reduction in mean rut depth there. We are doing a second phase at CSIR. That's how important this work is, with slightly different pavement configurations, and we'll keep you posted on those results. Just a quick discussion on lime stabilization now. So here we're going to look at comparing geogrid stabilization to lime stabilization, in particular in situ lime stabilization rather than plant mixed. Now, this graphic here is an application guide for geogrids originally, okay? And you can see that the applications are very wide in terms of subgrade type and subgrade strength, and the applications themselves. The range for lime, it is quite scientific. It is well studied, but it is quite a narrow range of application. Not really, or not suggested at all for organic clays, and you have to satisfy PI criteria and plasticity criteria for it to be applicable. So we'll talk about that in a bit more detail, but it's really horses for courses. Each have their own advantages and disadvantages. So I've spoken already about some of these stabilization advantages. Reducing thickness, increasing life, we've been able to demonstrate that, but also evening out differential settlement, particularly over variable subgrade conditions, improving bearing capacity, and then potentially capping over weak subgrades or voids. But a lot of the because there's so many different combinations of soil types, loading conditions, application areas, and geogrids themselves, we rely very heavily on observational techniques for performance. Lime, because it can be applied through those fairly narrow set of conditions for subgrade conditions, The benefits are quite well understood in terms of short-term drying, improving handling of the material and its conditions, reducing swell and plasticity. And the long-term benefits are pretty well understood in terms of its durability, strength, and modulus, and its strength gain. The impact on site is quite different between Geogrid and lime stabilisation. Okay, in Australia, where I'm based, using lime in urban areas is becoming quite frowned upon, and it's definitely not preferable. So yeah, just generally used in more rural or semi-urban areas. It does have a high mobilisation and demob costs, and which can have a significant impact for small to medium projects. Getting the stabilisation equipment out there on site can be expensive. Whereas Geogrid, very low impact. You're able to keep additional rolls in a depot or yard as a reserve or an insurance policy, and they can be deployed quite quickly and easily by hand. So if we talk about comparisons in terms of performance between Geogrid and lime stabilisation, I'm not going to cover all of these points, and you will get a PDF printout of these presentation slides. I'll just focus on a few here that are in bold. Soluble sulfates, if they're present in your subgrade clay, they can have a very detrimental effect to the stabilisation process, so they have to be identified up front. Composite stiffness. So you do need to consider the untreated subgrade as well as the treated depth as well, which is generally around up to about 300 millimeters in situ. It's potentially a reversible reaction, lime stabilisation with clay. And if you don't get the dosage rate right and under certain conditions, lime can potentially leach back out of the pavement system. For geogrids, it retains a free draining system in terms of the permeability characteristics of the stabilised aggregate. Okay, so it will retain its inherent permeability over a longer time period under a cyclic loading regime, because we're providing lateral restraint and reducing abrasion of aggregate particles. For lime, handling variability it can be an issue. Okay, so it may need, if you do have a variable subgrade that changes with the changes of the road at a high rate, then you need a very high level of testing and need good field or construction quality assurance. For installation, okay, we have a curing period up to 7 days that you have to work with for lime. If you are going to traffic that area, it does need to be sealed, so you need to think about that. For very heavy clays, high percentage of high clay content subgrades, you may have to add an additional, or you may have to add 3-day mellowing period to continue the stabilisation reaction with those heavy clays. And then in terms of installation, geogrids have appropriate, we've got over 40-year experience of installing our geogrids in very soft conditions, and we can give you guidance and appropriate techniques to assist you there. With lime stabilisation, it's and this is why it's not really used in urban areas, is because of the safety and environmental issues related to the dust and potential caustic runoff. So look, it's just in summary, it really is horses for courses. We do find that, particularly in our region, my region of Australia and New Zealand, lime can be over-specified, not always appropriate, but where they are used together in terms of maybe a lime modification to a swelling subgrade, and then geogrid use over the top of that to stabilise the aggregate and prevent any reflective cracking issues, they do work very well together. Okay, now this is the second part of my presentation, where I'll very quickly run through some Tensar Plus examples to give you familiarity with our cloud-based, freely available software package, which shows your value in terms of cost, time, and carbon. So once you register, and it's very simple to register, and as I mentioned, this is free to use, you'll see this typical landing page in your piece for your PC, where the application areas are down the left-hand side, and you have a bit of an introductory page. So the modules that I'll cover today in a bit more depth are the Aust roads module under the road application area, and proof roll also under road. So starting with Aust roads, it relates to part 2 of the or the pavement structural design guide, which is just currently being updated. We're not saying that this is specifically endorsed by Aust roads in any way. What we're saying is that for the non-stabilised sections, the sections where that Geogrid, you don't need to refer to the design charts to read off the thicknesses from your subgrade CBR and DESA. They're already provided and embedded for you within the software. So this relates to the standard chart of figure 8.4 and low volume roads, which includes figure 12.2. So the inputs are very simple. They're just in terms of subgrade CBR and DESA, design equivalent standard axles, and the outputs are thicknesses of layers and the grade of the Geogrid. So just to give you a bit of a handy reference for estimating subgrade strength for fine grain soils, for cohesive subgrades, this is a handy reference from our Australian standard, where it looks at hand and finger pressure, nail pressure, to gauge a range of subgrade CBR. Okay, there's also another way of doing this that I'll show you later on within the software. DESA is defined as design equivalent standard axles, 80 kilonewton axles that are equivalent in damaging effect on a pavement to a given vehicle or axle loading. That's direct out of Aust roads. And just remember to axle load, axle damage is not a linear relationship, it is exponential. And, we can see this from when we look at, corresponding ESAs of things like passenger cars to buses to trucks, and it depends on the weight distribution on the axles and their axle groups. So in pavement design, it's really the heavy vehicles that are considered, 2 and 3 axle buses, 2, 3, 4 and more axle truck. They're really considered in the pavement design. Light vehicles are generally ignored in the spectrum. So how is the Geogrid stabilised thickness calculated? We use a factor called structural number factor, which comes from AASHTO 93. As I mentioned before, that's been embedded in our pavement design software for a long time. And it's essentially the same. It takes into account the benefit of the grid and applies a reduction in thickness to achieve the same target DESA or equivalent standard axle loadings. It's the same as the layer coefficient ratio to reduce thickness. So let's have a quick demo of the key features of the Aust roads module. You'll find it under road, and then it's there. And here are your inputs highlighted in the green boxes. The main ones are DESA and subgrade CBR. Then the chip seal surface, that's selected by default. The particle size for the base and subbase, that governs selection of the Geogrid, whether it's a standard or a large aperture Geogrid. And then you have the option there as well to add a geotextile separator, so a non-woven geotextile below the Geogrid. It doesn't affect the pavement structurally. It just just shows it on the on each of the sections. So then if we switch to the value tab, all of these fields, they're editable. Okay, they can be changed by the user, and we suggest you do this on a project by project basis. Make sure you've got relevant data. Also, there's a function here for project area. Okay, so you can calculate from length and width the area, and you can add successive sections. So for things like a residential development with a lot of roads, or a renewable energy development, this could be quite useful. And just as a tip, ensure that the costs are the same between stabilised and non-stabilised sections. Sometimes you may have configurations where the stabilised section is slightly different to the non-stabilised, and sometimes the costs may not be carried across appropriately. So just double check that if you see things funny that are happening with these column charts for cost, time, and carbon, which show you the savings. Okay, I'll talk about the proof roll module now. What is it? A proof roll's a way of assessing strength, stiffness, and uniformity, compactive effort of material by moving a heavy plant over the surface and then observing either deflection or deformation. And this is from Aust roads. It can be done on earthworks, it can be done on pavement foundation or pavement structural layers. They're usually project-specific deflection deformation limits. This gives you an example of a typical proof roll vehicle. Okay, they can be dump trucks, water trucks, or loaders. And in Australia, Australia and New Zealand, we have a guide called from Austroads called ATM 440, which was just republished earlier this year. And it's quite a nice, brief, succinct guide to proof rolling without being too specific. Okay, and a lot of times we're asked to fix failed proof rolls where, we'd really like the software to be employed before this happens, and just make sure you have the best chance of success. So to demo the key features of this software, it's here under Road, and there are tooltips which are shown as question marks, which give you more information on specific aspects of the inputs and sometimes the outputs. So this one gives you more information on the proof roll vehicle, and then you can look at different options for the proof roll vehicle through that drop-down button there. So you've got dump truck, water truck, and a couple of loaders. Also the ability to put in a custom vehicle. For the deflection or deformation targets, you've also got 4 options there. So you can set that target appropriately, just depending on how critical your project is. You've got some basic inputs for the aggregate. If we click on the CBR tooltip, the question mark, it takes us to this little guide, which is similar to the one I previously showed you from the Australian standard. But this relates to trafficking of the subgrade in terms of walking or driving over it to estimate subgrade CBR. So slightly different guidance. If we click on the CBR calculator, in there are correlations from undrained shear strength. If you've done some shear veins, you can correlate that to CBR, but there are 3 different correlations, and just be careful with them. Don't always use the one that gives you the most favourable CBR. Use appropriate care and judgment depending on the criticality of the project. There's some recommendations here as well, which I urge you to read, that give you background on the module. The main one here is this number 1, where it defines what the proof roll test is based on, up to 10 passes of the proof roll vehicle travelling up to 8 kilometres an hour. Okay, so and looking at the deformation after that. There's also some other guidance there on the aggregate type and how to deal with particularly moisture sensitive subgrades and saturated subgrades. So, those are also important to consider. If we then switch to the value tab, we can see different options. Once again, we can see the column charts showing us the savings in cost, time, and carbon. We look at the excavation options, okay, and they can be just meeting grade, either above or below the existing grade, so showing a height or depth. And then in this particular case, what we've got here is quite a significant saving in construction time, and this might be the key factor, the key decision maker for this project, and this could really affect the overall length of time for this project. So if you can avoid rework and you're already saving 50% in construction time, that may be the key factor in using this proof roll module. Just to show you also our resources section. Okay, so this is important too to give you background, and it relates to case studies, installation guides, but also white papers for each of the application areas: road, working platform, rail, and foundations. There's some key white papers here which give you, background information on how these methodologies have been derived. So if we just click on one of those, it opens up a web page where you can access or download that particular document like that. Then for specifications, these are available through the purple button you can see here. And they are performance specifications, which if you then decide to print, they're not at all related to index properties of the grid. They're related to the performance aspects specific to your particular design. Okay, and then these can be added into your project specifications. For more options, I'll probably just highlight this. One of them, without one of the arrows, is currency. I've just recently been in New Zealand, as you can see. So the currencies are shown in New Zealand dollars. This is where you can change to rupiah. I know a lot of the audience will be from Indonesia, so this is where you change to your local currency. You've also got additional options in terms of the print output. And if we look at that, it's separate to the specifications, but it gives you a summary of the input parameters, the two different sections, the cross sections, and the output. Summarizes all that quite nicely for you. The designs can be shared with colleagues or other people. You do need to save your design first, and then you can share it. And it can be done in one of two ways: directly via email, or you can just copy a link and then paste it into another email if you like. So just on the key takeaways, for the Austrades module, I'd encourage you to play around with any of the modules within Tensar Plus, but specifically because I've showed you the Austrades module, look out for opportunities to economize on the stabilized sections using the single aggregate layer design option. I didn't get time to explain that today, but you're welcome to play around with that. And you also have a customize button. So there's things that you can do. You can adjust, you can turn aggregate layers on or off and adjust thicknesses and add geogrids using the customize button. And always use project-specific costings for everything. For the proof roll module, just investigate the sensitivity to different vehicle types, the deformation targets, the subgrade CBR, and in particularly subgrade type. If you input silts and fine sands, and then you may have an option for the waterbed effect. That has a significant impact on the proof roll thickness, proof roll platform thickness. So play around with that and become familiar with inputs for custom proof roll vehicle types. They are quite specific. So just the key takeaways from this presentation before I finish. The lateral restraint of the aggregate provided by the stabilisation geogrid gives you improved subgrade bearing capacity, enhanced aggregate resilient modulus, improved compactability over weak variable subgrades, and enhanced rutting resistance of the pavement structure. So through our research, we've been able to prove all of those, each of those concepts. Where chemical stabilisation may be over-specified or it may not be appropriate, geogrid stabilisation is a real option. The software it has a range of paved road modules, and as well as a lot of other things that can show effective designs in terms of value, which we measure as cost, time, and carbon. Okay, time for any questions, please. Thank you. Arifa, do we have the questions in the chat?
Okay, thank you, Pak John, for insightful presentation on Geogrid technology in paved road application. Jika
Thank you.
Bapak Ibu ingin bertanya kepada Pak John, silakan mengirimkan pertanyaan di feature Q&A dalam bahasa Inggris. Perkenalkan, saya Wira yang akan melanjutkan sesi ini dengan membawakan produk-produk inovatif dari PT Multibangun Rekatama Patria. Oke, PT Multibangun Rekatama Patria merupakan perusahaan yang bergerak di bidang industri geosintetik. Adapun visinya yaitu menjadi pemimpin pasar dalam industri produk geosintetik Indonesia yang selalu bersaing dengan sehat. Multibangun bukan hanya sekedar penyedia produk, tetapi sebagai mitra bisnis strategis Anda yang telah berpengalaman lebih dari 27 tahun dalam industri konstruksi, khususnya untuk produk geosintetik yang kualitasnya sudah teruji berstandar internasional. Dan untuk ketersediaan produk, stok dipastikan sudah tersedia di gudang kami. Berikut ekosistem solusi geosintetik kami yang secara komprehensif, mulai dari perkuatan lereng atau DPT, kemudian ada stabilisasi tanah dasar, hingga lapisan kedap air. Nah, perlu diketahui Bapak Ibu, kami merupakan distributor tunggal dari produk Geogrid Tensar Internasional dan distributor geomembran dari merek Vitex. Berbicara mengenai perkuatan lereng, kami tidak menawarkan satu solusi untuk semua masalah. Kami menyediakan portofolio sistem dinding penahan tanah yang dapat disesuaikan dengan kebutuhan spesifik proyek yang Bapak Ibu butuhkan. Ada 3 tipe dinding penahan tanah yang kami tawarkan, yaitu dari multi-block retaining wall system, kemudian ada shell-scape retaining wall system, dan wrap-round system. Nah, ketiga DPT ini itu hanya dibedakan oleh facingnya saja, namun untuk perkuatannya itu menggunakan Tensar Geogrid Unexial. Oke, multi-block retaining wall system ini merupakan dinding penahan tanah segmental yang terdiri dari modular blok beton sebagai facing, kemudian ada Tensar Geogrid Unexial sebagai perkuatan tanah, dan konektor sebagai penghubung antara Tensar Geogrid Unexial dengan modular blok beton. Secara keseluruhan, multi-block retaining wall system ini dipasang tegak dengan kemiringan mendekati 86 derajat. Berikut proyek yang kami sudah kerjakan menggunakan multi-block retaining wall system, yaitu pada jalur kereta Bandara Batu Ceper, Bandara Soekarno-Hatta, yang berlokasi di Tangerang, Banten pada tahun 2017, dengan ketinggian dinding 10 meter dan sepanjang 2 kilometer. Dan yang terbaru itu kami juga sudah mengerjakan di overpass di Kota Baru Parayangan pada tahun 2004 di Padalarang, Jawa Barat dengan ketinggian dinding 9 meter. Nah, proyek-proyek berskala besar ini membuktikan bahwa pilihan multiblok sebagai solusi yang sudah teruji dan andal untuk infrastruktur kritis. Nah, untuk shell-scape retaining wall system ini merupakan sistem dinding yang dirancang untuk kekuatan dan fleksibilitas maksimal. Sistem ini mengandalkan Tensar Geogrid Unexial yang dihubungkan dengan welded wire galvanized sebagai facing dan kemiringan 75-86 derajat terhadap horizontal. Keunikan utamanya dari shell-scape retaining wall system ini yaitu bisa memilih untuk facing-nya, bisa menggunakan tumbuhan atau rumput, kemudian ya kalau mau tampilan industrial yang kokoh bisa menggunakan stone fill. Untuk proyek menggunakan shell-scape retaining wall system, kami sudah mengerjakan di area pertambangan di Sumbawa, Nusa Tenggara Barat pada tahun 2023 dengan ketinggian itu 27 meter dengan luas area permukaan dinding sekitar kurang lebih 4.000 meter persegi. Dan yang kedua itu di Jembatan AFL Doho Airport Kediri pada tahun 2022 dengan ketinggian 13 meter dan panjang luas area sekitar 1.400 meter persegi. Selain itu, kami juga menawarkan wrap-round system yang mengkombinasikan Tensar Geogrid Unexial dengan soil bag sebagai facing dan kemiringan 50-75 derajat. Wrap-round system ini mengedepankan efisiensi dan adaptabilitas Dan adapun penggunaan web front sendiri ini kami sudah mengerjakan di area crusher plant di Cariu, Bogor, Jawa Barat pada tahun 2019 dengan ketinggian setinggi 10 meter, dan juga di crusher plant di Lampung tahun 2017 dengan ketinggian 10 meter juga. Sekarang kita beralih ke stabilisasi tanah dasar. Nah, kita semua pasti familiar dengan masalah seperti tanah ekspansif, tanah lunak, tanah gambut. Nah, akibat itu kita pasti jika kita mengabaikan kondisi tanah seperti ini, jalan pasti bergelombang dan mengalami penurunan setempat. Kemudian kendaraan berat terjebak dan tidak bisa melintas. Kemudian yang paling krusial yaitu timbunan material sulit untuk dipadatkan, yang berarti pemborosan dan waktu dan biaya. Nah, pertanyaannya, mengapa ini terjadi dan apa solusinya? Jawabannya terletak pada dua prinsip rekayasa geosintetik. Jika dalam jangka panjang, interlocking pada geogrid Tensar Inter-X jauh lebih efektif daripada tension membrane dari geosintetik separator karena cara kerjanya yang proaktif dalam menjaga kekuatan tanah. Sederhananya, interlocking ini mencegah kerusakan sejak awal, sedangkan tension membrane ini hanya menahan kerusakan setelah terjadi. Jadi, penggunaan Tensar Geogrid Inter-X pada jalan yang didesain ini agar awet dan minimum perawatan. Mekanisme interlocking ini dari Tensar Inter-X adalah pilihan yang jauh lebih unggul karena ia mempertahankan integritas dan kekuatan struktur jalan selama masa layanannya. Nah, pada tahun 2004 kami dipercaya melakukan stabilisasi tanah dasar di Pelabuhan Sunda Kelapa di Jakarta Utara pada tahun 2024 kemarin, bisa dilihat pada gambar kiri menunjukkan tanah yang lunak sehingga direkomendasikan menggunakan Geogrid Inter-X, Tri-X. Nah, proyek di kawasan industri strategis ini sepertinya tentunya menuntut standar yang tinggi dan kami berhasil memenuhinya. Ini menunjukkan bahwa solusi yang kami tawarkan merupakan pilihan utama yang andal. Kemudian kami juga sudah mengerjakan di proyek perkuatan jalan akses Pertamina Aset 2 pada tahun 2019 di Palembang. Pada gambar sebelah kiri adalah kondisi sebelum. Ini menunjukkan jalan yang berlumpur hingga tidak bisa dilewati oleh kendaraan. Nah, di sebelah kanan itu adalah kondisi sesudah. Jadi jalannya sudah menjadi stabil dan kokoh dan siap untuk menahan beban berat. Transformasi ini adalah bukti kekuatan teknologi stabilisasi kami menggunakan Geogrid Tri-X. Nah, jika Bapak Ibu ingin bermitra bersama kami, pastinya kami menawarkan produk yang lebih dari sekedar produk. Kami memberikan keahlian yang terbukti sejak 1998, kemudian kami memberikan akses ke produk eksklusif dan berkualitas sebagai distributor tunggal dari Tensar Geogrid dan kemudian geomembran dari Huitex. Kami juga menyediakan solusi yang komprehensif untuk setiap tantangan dan tentunya kami juga memiliki rekam jejak konstruksi yang tersebar di seluruh Indonesia. Dan yang terpenting, kami juga memberikan dukungan khusus dari tahap desain hingga implementasi. Demikian peran singkat kami. Bagi Bapak Ibu yang ingin berkonsultasi, silakan hubungi nomor yang tertera atau bisa mengunjungi website kami di www.multibangunpatria.com. Terima kasih. Okay, we will continue to Q&A session. Pak John, the time is yours.
Okay, thank you, Wera. Look, I've got the questions, so I'll try and I'll try and attempt to answer the shorter questions first. So one of the questions was, can the installation of this geogrid be done by local workers? Does it require special expertise? In most cases, it can be done by local workers with some very initial training or basic training by either Tensar themselves or the local distributor. So a lot of applications that can be done. It's just special expertise is when you're on very soft soils, and I class that as soils that you can't walk on. very soft, maybe marine clays that are highly mobile. And, if you can't walk to lay out the grid, you do need, maybe special equipment in terms of mandrels to lay out the grid, and special earth-moving equipment to deploy and lay out the aggregates as well. So that's the only case, but that'd be a fairly low percentage of our applications. In most cases, it can be done with local experience. When should a geogrid be placed directly on the subgrade, and when is it more effective to place it between subbase and base course layers? There's a couple of questions there from Ispamo, and that's the first one. I think directly on the subgrade, where that once again, that's most of the cases, because we are working with softer subgrades. You do need to be able to traffic that, and in a lot of cases, we're forming maybe a profile platform or a construction platform to be able to build something above it. So, that can be a geotechnical solution, but also for a pavement structural solution, it's most typically deployed on the directly on the subgrade, just to make sure that you can achieve your compaction targets in the subbase and base courses. Cases where it may not be deployed on the subgrade, but installed under a base course with a subbase below it, could be on a stronger subgrade, and you have particularly high either wheel or track loads at the surface. So that may be a case where it's placed higher up in the pavement structure. Ispamo has also asked, for soft subgrade stabilisation, when should we roll out the geogrid along the road alignment, and when should we lay it across the road's width? That's a good question, and in pretty much most cases, it's longitudinally to the parallel to the alignment of the road. There are cases, however, and I've experienced those in my region over peat subgrades, where it's best, if you can, to lay across the width of the road. So it's a full width construction or reconstruction, because in some cases, particularly in New Zealand, where we have peat subgrades, they're quite mobile, and what we found is if we lay longitudinally, and the table drains adjacent to each edge of the road are quite deep, we can end up with, even with the geogrid, the longitudinal overlap separating, because those forces are very high. And that's a case where we should lay it across the road in the full width, so that each side's really in equilibrium. Okay. I'm getting a few more questions here. From Sir Herman, can geogrid also reduce settlement if it's applied to under-consolidated soft soil? In terms of total settlement, it doesn't have an impact. But in terms of differential settlement, yes, it can mitigate the effects of differential settlement over prone soft soils, but in 2 or more layers to act as a stiff beam to mitigate those effects. So, yes, that's possible. Anthony has asked, can geotextile layer between aggregate base and chip seal surfacing improve the system performance and durability? A geotextile potentially can, but not a geogrid. Our geogrid has got quite a high aspect ratio, so that means the ribs are quite tall, and that wouldn't work with chip seal, unfortunately. Sorry, I'm just going back to some of the other questions, the earlier questions. From Aging, he's asked about, he's mentioned the World Bank infrastructure report from 2022. Poorly maintained and unstable roads can increase logistics costs by 30 to 40%. Would agree with that, especially in developing countries and rural areas. So I'm wondering, when using geogrids to improve base stabilisation, has there been a cost-benefit analysis or life cycle cost comparison that shows how much budget can be saved in the long run compared to traditional reinforcement methods or traditional non-stabilised methods in general, especially in low to middle-income countries, this kind of data could be very important to justify the upfront investment in Geogrid solutions. So this is where I'd point you towards the software. And there's a specific module in Tensar Plus called the Asphalt Pavement module, and it's been renamed as, it was previously known as the Spectra module or AASHTO 93. In there, they have a life cycle cost calculator in the value tab. So if you can get into Tensar Plus and have a look at that Asphalt Pavement module, you'll be able to see that life cycle calculator there. And once again, just encourage you to use your local costs so they're directly relevant to your area. From Dwee, thanks for the insightful explanation. Many countries with tropical climates like Indonesia and the Philippines frequently experience pavement failure due to high rainfall and waterlogged subgrades. How do geogrids perform in such saturated environments over the long term? Are there any specific field studies or case reports, especially in Southeast Asia post-2020, that show how well geogrid stabilised base layers maintain stiffness and prevent rutting under high moisture conditions? Part of this question, I'd probably revert back to MRP for some of their local experience in Indonesia. I'm sure they've got plenty of examples that have had those conditions. From my experience in Australia and New Zealand, we've had quite significant rain events over the last 5 or so years in particular, and we've got some anecdotal experience that our stabilised pavement sections have held up a lot better and have been more resilient under high rainfall events than their non-stabilised counterparts, immediately adjacent to them. So, in approaches to bridges over creeks that have experienced a high level of flooding and actual sort of culvert crossings and overflows that have been stabilised with our geogrids, they've anecdotally exhibited a lot more resilience than without. We do have that, but I think that's probably a local question. So I'd probably revert to Multibangun on that one locally for Indonesia to help you out with any case studies there. Just looking at the other questions. Settlement I've covered. Okay. Yuga has asked, pavement design with geogrids can be more efficient, but one of the pricing factors that must be considered is the cost of delivery to the site. How does Tensar Indonesia reach remote areas, such as mining sites? I often encounter clients who refuse to use geotextile products and rely solely on conventional pavements. Well, look, I think MRP have got a lot of experience, and even quite recently, we've supplied quite a few major mining projects that are quite remote. Batu Hijau and the current project Freeport, some that I can think of. They're not stabilisation geogrid projects; they're actually reinforced soil projects. But MRP have done a very good job of supplying those very cost effectively. Now, in terms of pavement design, once again, I'd steer you towards Tensar Plus and the relevant pavement design module, because there you're applying in the value tab, you're applying the install cost of the geogrid. So, get the freight costs from MRP or your local distributor direct to site, make sure that covers everything that's delivered to site. And then you add in your installation costs on top of that. And that's the cost that you plug in directly into the value tab for your geogrid install cost. Once again, make it project specific as much as possible to get a true representation of the geogrid benefit for you. And hopefully then you can convince your client to use you show a net saving, and you can convince your client to adopt the product. From Albert, before installing the geogrid, is it still necessary to test the soil CBR layer by layer? What is the maximum layer before compaction? What is the soil CBR value increment after installing the geogrid? Look, I think it comes down to, how deep you go, I think that's what you mean, Albert, for the CBR testing. Depends on the depth of influence for your particular application. Pavements are generally fairly light, but something like a temporary working platform for maybe a very heavy crane, the track of a very heavy crane might have a very deep depth of influence. So you'd want to structure your geotechnical investigation accordingly. Maximum layer before compaction. Generally the minimum layer thickness over the geogrid is anywhere from 100 to 150 mil of aggregate, okay, depending on your maximum particle size. So that will also govern the maximum layer for compaction. What is the soil CBR value increment after installing the geogrid? I mentioned that fairly early in my presentation. It's very site dependent, but the example I gave was a resilient modulus increase of around 30 without the geogrid to about 50 with the geogrid. But there's a variety of published papers available that try to quantify this, but they also mention it's very case specific. If you do want to get any of those papers, please contact either myself or me through Multibangun. From Ari, and this is the final question, can this geogrid be used for improvement of expansive soil types? Yes, it can, definitely, but there's a limit to it. So the very extremely swelling or extremely expansive soil types, and they're characterized by surface movement, we'd suggest looking, if the CBR swell is in the double figures, so 10 and above, we consider looking, and that's a case where you consider a lime treatment to that to reduce it, maybe down to a H1 or a moderately expansive soil type in terms of movement, and then employing the geogrid above it. Okay, but we've got a lot of anecdotal evidence that it does improve pavement performance over swelling clays and reactive clays. So yes. That seems to be all the questions. Thank you for those. Thanks for your interest, and I'll hand back to Tansy now and Reefa for the games. Thank you.
All right, John, thank you for your excellent presentation and all your answers to the audience's questions. Bapak Ibu, terima kasih atas pertanyaan-pertanyaan yang masuk, utamanya terkait dengan kasus-kasus lokal kami. Maka kami dari Multibangun akan dengan senang hati menjawab pertanyaan Bapak Ibu. Jika berkenan, dapat menghubungi kami via WhatsApp atau mengunjungi website kami setelah acara ini selesai. Sebagai informasi, kami juga telah meluncurkan WhatsApp Community Multibangun Engineering Hub, sebuah wadah komunitas untuk Bapak Ibu mendapatkan informasi terbaru terkait event kami, artikel, dan informasi lainnya dari Multibangun. Selain itu, komunitas ini juga menyediakan wadah diskusi dan tanya jawab seputar solusi geosintetik yang cocok di proyek-proyek Bapak Ibu sekalian. Baik, Bapak Ibu, bagaimana paparan dari John Buckley dan juga dari Mbak Wira tadi? Boleh dong Bapak Ibu dijawab melalui poll yang baru saja muncul di layar Zoom Anda. Semoga apa yang disampaikan dapat berguna dan bermanfaat dan diterima dengan baik. Baik, kita tunggu untuk Bapak Ibu isi poll Zoom-nya sebentar. Boleh dari tim di-share hasilnya? Silahkan dijawab pollnya yang sudah muncul di layar Zoom Anda. Setelah ini kita masih ada kuis berhadiah, jadi Bapak Ibu jangan kemana-mana. Oke, sudah banyak yang masuk dari poll. Wah, terlihat ya bahwa informasi yang disampaikan oleh John Buckley dan juga dari Mbak Wira ini secara garis besar very useful and engaging. So thank you John Buckley for the presentation and for coming to our webinar. Also Mbak Wira,
Thanks, Rifa.
terima kasih sudah memaparkan presentasi terkait multibangun, produk dan juga service-nya. Nah, karena sudah pada isi poll nih, dan juga ternyata masih pada banyak ya yang stay sampai akhir, maka tanpa berlama-lama lagi, kita langsung saja beralih ke sesi selanjutnya, yaitu kuis berhadiah. Bapak Ibu, saya mau informasikan bahwa kuisnya ini boleh diikuti oleh semua orang, tapi hanya peserta dari Indonesia yang eligible atau yang berhak untuk mendapatkan hadiah dari kuisnya. So everyone, you can join the quiz, but only those who live inside Indonesia are eligible to get the prize. Jangan lupa nanti setelah diinfokan tentang kuisnya, daftarnya pakai nama yang sudah dicantumkan di Zoom ya, supaya tidak tertukar begitu. Nah, kuis berhadiah ini nantinya akan dipandu oleh tim kami dari Multibangun, yaitu Tanti. Langsung saja kepada Tanti, dipersilahkan.
Selamat pagi, Sobat Multibangun. Selamat datang di sesi yang paling ditunggu-tunggu. Jadi, terima kasih kepada para peserta yang sudah hadir mengikuti rangkaian acara webinar hingga akhir. Oke, perkenalkan nama saya Nanti dan saya akan menjadi host untuk kuis pada hari ini. Oke, sebelum gamesnya kita mulai, saya ingin bertanya dulu nih. Siapa yang dari awal hingga akhir itu masih ada di webinar hingga saat ini? Boleh dong dikasih thumbs up-nya. Saya mau tahu dulu siapa di sini yang masih hadir. Ayo, ayo, ayo. Boleh dong. Oke, udah banyak banget ya. Oke, terima kasih kepada para peserta yang sudah memberikan reaction-nya ya. Oke, jadi sebelum games ini kita mulai, saya akan membacakan rules-nya terlebih dahulu. Jadi nanti kuisnya ini ada 5 pertanyaan, di mana 3 pertanyaan itu sudah dibuat oleh Bapak John Buckley, dan ada 2 pertanyaan dari marketing kami, Mbak Wira. Dan tenang aja, pertanyaan tersebut itu tidak jauh-jauh dari materi yang sudah dipaparkan tadi ya. Oke, selanjutnya nanti akan ada hadiah menarik dengan total senilai 750.000 dalam bentuk e-money untuk 3 orang pemenang. Pemenang pertama akan mendapatkan 300.000 dan yang pemenang kedua akan mendapatkan 250.000 dan pemenang ketiga akan mendapatkan 200.000 rupiah ya. Oke, tanpa berlama-lama mari kita mulai aja kuisnya. Jadi silakan Bapak Ibu dan rekan-rekan semua untuk membuka browser dari ponsel boleh, dari laptop juga boleh. Ini di samping saya ada web QR-nya, sudah ada websitenya juga menti.com dan boleh dimasukkan kodenya 28768484. Sekali lagi boleh langsung ke www.menti.com, boleh scan QR code-nya dan masukkan ke kode 28768484. Oke, sebagai tambahan juga ya, Bapak Ibu, masukkan nama teman-teman di Menti sesuai dengan nama registrasi. Tujuannya agar panitia dapat dengan mudah melakukan verifikasi data saat menentukan pemenang ya. Jadi saya akan memberikan waktu sebelum kita mulai. Oke? Oke, udah masuk semua ya. Yang belum join, ayo dong. Mumpung 750.000 nih. Iya 750.000 hadiahnya. Oke. Oke, kita mulai dari 5, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oke, pertanyaan pertama. Is the stabilization geogrid able to increase the confining stress within its zone of influence in the aggregate above? Yes or no? Hayo, apa nih jawabannya kira-kira? Yes or no? Ayo, 1-0. Jawaban yang benar adalah yes ya. Oke, ada 4 nih yang salah nih. Yang jawab no. Oke, kira-kira siapa yang pemenangnya? Pemimpin ya. Oke, ada Rahga Damar Uliandarila mendapatkan poin sebesar 978, diikuti oleh Justian dan Zulfitriansyah Putra. Oke. Kita lanjut ke pertanyaan kedua. Oke, kita mulai ya. Pertanyaan kedua, boleh? In relation to intelligent compaction, what does MDP stands for? A. Management Development Program. B. Machine Drive Power. C. Manufacturer Digital Platform. Apa nih jawabannya nih? Ayo. Yang pemimpinnya kira-kira masih juara 1 nggak nih? Kita lihat. No. Yap, yang benar adalah B. Machine Drive Power. Yeay. Kita lihat siapa pemimpinnya. Oke. Oke, berubah ya. Jadi Yuga Lendistanu nih yang pemimpinnya nih dengan poin 1918, diikuti oleh Albert Daniel dan Hangul yang yang ketiga. Oke, kita lanjut ke pertanyaan ketiga. What are the 3 main value metrics that Tensar shows in stabilized versus non-stabilized comparisons? A. Cost, time, and carbon. B. Thickness, fuel, and water. C. Tire wear, distance, and truck type. Ayo, jawabannya apa ya? Apakah A? Apakah B? Atau C? Iya, benar jawabannya adalah A. Cost, time, and carbon. Oke, siapa pemenangnya? Oke, pemimpinnya masih Yoga Lendistanu ya. Mendapatkan poin sebesar 2.854, diikuti oleh Albert Daniel dan Laura Fahmi. Nice, oke. Kita lanjut ke pertanyaan keempat. Kita mulai. Sistem dinding penahan tanah multibangun yang menggunakan soil bag sebagai facing adalah A. Sierra Scape Retaining Wall System, B. Multi-block Retaining Wall System, C. Wraparound System. Apa ya jawabannya ya? Saya tahu sih jawabannya. Bener, jawabannya adalah C. Wraparound System. Banyak yang salah ternyata ya. Waduh, siapa nih pemimpinnya nih? Wah, keren. Berubah ya, jadi Albert Daniel nih yang pemimpinnya nih dengan poin 3.782, diikuti oleh Femi Andiani dan yang ketiga adalah Tavera Wiharja. Oke, ini pertanyaan terakhir nih. Lanjut aja. Siapa nih kira-kira yang mendapatkan imani nih 300.000? Oke, next. Apa salah satu masalah yang dapat terjadi pada tanah dasar yang lunak, ekspansif, atau gambut? A. Terjadi penurunan setempat, jalannya bergelombang. B. Peningkatan daya dukung tanah. C. Peningkatan kekuatan geser tanah. Ayo. Ayo yang cepat. Yang cepat jawabnya. Biar kita tahu siapa pemenangnya. Nggak sabar. Yes, yang benar adalah terjadi penurunan setempat. Ada 32 nih yang benar nih. Siapakah yang berhak mendapatkan imani? Kita lihat. Congratulations kepada Albert Daniel mendapatkan poin sebesar 4.716 poin. Dan diikuti oleh Femi. Dan yang ketiga adalah Tavera Wiharja. Oke, congratulations to all the winners. Tepuk tangan guys. Thank you. Oke, selamat untuk para pemenang. Dan untuk para pemenang, jangan lupa screenshot hasil kuisnya hari ini. Karena itu berguna untuk sebagai proses verifikasi pemenang ya. Jadi, saya ucapkan terima kasih banyak kepada para peserta yang sudah mengikuti kuis pada hari ini. Semoga bermanfaat dan semoga ilmunya juga bermanfaat tentunya. Dan jangan lupa untuk bulan depan akan ada webinar juga. Jadi tetap ikutin terus webinar dari Multibangun Engineering Hub. Oke, perkenalkan saya Tanti, saya pamit undur diri. Terima kasih semua.
Baik, Bapak Ibu, dengan berakhirnya games tadi, maka sudah sampailah kita di penghujung acara. Untuk informasi mengenai sertifikat dapat diakses melalui link tr.ii/mrp webinar yang juga tertera pada kolom chat atau yang tertera pada layar Anda. Kalau misalnya linknya belum ada, mohon ditunggu sekitar 5 menit setelah eventnya berakhir, baru nanti diklik link tr.ii/mrp webinar. Nanti akan ada survei yang bisa diisi, singkat saja surveinya. Nanti kalau sudah selesai, baru nanti ada link menuju ke sertifikatnya. Nah, apabila Bapak Ibu memiliki pertanyaan atau terdapat kesalahan penulisan nama pada sertifikat Anda, silahkan hubungi saya Rifa melalui WhatsApp di 0811-127-1414. Untuk informasi lebih lanjut terkait PT Multibangun Rekatama Patria, dan juga acara-acara kami selanjutnya, Bapak Ibu bisa mengikuti media sosial kami, ada LinkedIn, Instagram, TikTok, YouTube, dan Facebook. Untuk melihat tayangan ulang pada hari ini, juga bisa mengunjungi kanal YouTube Multibangun. Bapak Ibu dapat mengakses berbagai video informatif, edukatif, dan tentunya seru terkait dunia konstruksi, khususnya geosintetik. Baik, akhir kata saya mewakili segenap panitia mengucapkan terima kasih kepada seluruh peserta, pembicara, dan panitia yang terlibat dalam acara ini. Saya juga memohon maaf jika terdapat kesalahan pada penyampaian selama acara berlangsung. Kami menunggu Anda di Multibangun Engineering Hub webinar selanjutnya di bulan depan. Saya Rifa, pamit undur diri, sampai jumpa dan selamat siang.